A little bit weird here. It was weird to set the live stream, and kind of weird when I went to the main page. It said something went wrong, so I'm not really sure. There's something up with YouTube. I'm gonna stay here for 1 hour and a half, I think. Hopefully it doesn't break in the middle. And I wanted to leave the title open-ended, but I think I'm probably gonna continue to work on the website, but I'm not 100% sure that I want to do that now. So when I was doing this, I searched a little bit more for different libraries, and then I find out that there is this library called ngraph. And once I figured that out, I explored a little bit, and then I realized that you used WebGL, and I didn't know what WebGL was. So, and I remember hearing about it, but I didn't know exactly what it was at the time. Like, it was a long time ago, I think. So I had no idea, like, what was the point. So I started researching, and then I decided that it's probably the best decision is probably to try to do everything with this library instead of trying to do with Vue.js. And the way that it works, as far as I understand right now, WebGL, is that it allows you to use the GPU for computing and creating graphs. And it also allows you to create 3D graphs. And it seems to be exactly what I was looking for. And I also use ChatGPT to help me to ask questions about like the trade-offs between this framework and the other ones for creating graphs. And it seems like this one is the best for updating graphs live and also for large graphs because it's much faster. But the downside of this is that I have to learn WebGL, which is, from what I've seen, can be complicated, I think. And I spent a bunch of time watching a bunch of videos and already about WebGL, but I didn't do anything, obviously. So it's gonna be tough to figure out. The other thing that I was looking into, and I've seen some videos today, which I think I kind of agree, that AGI might happen a lot sooner than people would think. So there is this one guy that was making the prediction for 18 months, I think, from now, which is pretty crazy to think about. And then I went into this rabbit hole, and then I started looking into this, and then I found out about this stuff here, which is LangChain, and I also started looking into the OpenAI thing here. And then I also found out a guy on Twitter that he pretty much created an agent that uses the inputs from ChatGPT to search. I'm not sure if it's ChatGPT or GPT-4, don't remember. But he uses the inputs and then creates something that uses the inputs to search on the internet and to create other inputs. So it's like he made the ChatGPT talk with itself pretty much, and using search from the internet to find answers. It's pretty fucking crazy if you think about it. So that is obviously something that is really interesting, and I'm not sure if there's probably nothing we can do about it, so it's gonna happen. So like, might as well study and try to build something with it, or try to maybe think if I can incorporate this on the stuff that I'm doing, and then try to figure out a way to merge the blockchain or whatever with this. But I think it's like, from this point, I think that most people agree that it's very unlikely that we'll be able to stop. But yeah. So I think potentially what I might do is try to incorporate the OpenAI on this website here as well, and see if he can like maybe read the code and help me. Or the other thing I was thinking about it is just using the API to create something that read all the files of the project and then parses the files, like what I'm doing here. But instead of building the graph, I use the OpenAI thing, OpenAI API to allow ChatGPT to read all the code and then see if I can create something that makes the thing reason about the entire code. But obviously, like the whole point where I still haven't done anything with this API here, even though that it has been out for some time, is because I'm not 100% sure. Like, it's very hard to think about these things because maybe, like, obviously, there's no way for me to tell if I build anything, if it's gonna create something that is out of proportion and I don't understand it. So that's the problem. And it seems like, well, maybe it seems hard to believe that you would create anything that would have those consequences, but I think that it might be possible, especially because I'm streaming as well. So, and then other people get ideas, but I think that is kind of inevitable. But it's really hard to think about it, to decide like whether or not to use these tools or not, or like what to do about it, because it's extremely complex. So I copy a bunch of repositories from this, and it looks like the documentation for this is just on this Git repo, and then it has all the links here, and then I copied a bunch of these GitHub repositories. I just forked them, and I think I was looking. Yeah, this one is an example of one of the repositories of the graph. So I think I'm gonna copy this stuff here. I was thinking about it initially to. I think I actually am gonna do that as well, but I think for now I'm just gonna create a file. So I was thinking about I created another file here, ngraph, and then just downloading all the repositories that are forked here. So I have all of them to work with. But I think first what I'm gonna do is create another file here. Maybe in stars. It's kind of tricky because I don't know Svelte really well. So it's hard to think about how to manage this, like if I have to create stores or not, like what to do with this. Oh, the other thing that I wanna look into is how to use GPT-4. I'm not sure, because I've seen people in Twitter talking about it, so I think it's possible to use GPT-4, but I think the one that I'm using here is ChatGPT. And obviously there is a difference between them, I think, because ChatGPT, from what I know, uses GPT-3 or GPT 3.5 or something like that. So let's see if there's a way to choose the other one. But I assume that you might have to pay, and I joined this list for using the API as well. And also I've seen some stuff that they are making something to sign on slowing down the progress or something like that, but I didn't look too much into it. But I think at some point, like, people should come to an agreement, because like even though there are, like, people always talk about China, Russia, and North Korea, I think, but like their values can be out of alignment with the values of other countries, but that doesn't mean that they are stupid. So I think everyone should understand rationally that it's kind of like nuclear weapons or things like that, but at 100 or billions of times or infinite amount of times worse, because the multidimensional problem is extremely, like, the danger is far higher than nuclear weapons. And it's a much more difficult problem to control. So I think that people should come to an agreement at some point, because everyone understands this, and it's like everyone's being held back by the game theory aspect of the arms race, that we can stop it, because then otherwise they will do it. But if you think about it, it's like really dumb. Like, at some point, I think some people need to let go of the control, and just I think that's the main thing. Like, if it reaches a tipping point where enough people let go of the control because they realize that is inevitable to lead towards bad outcomes if it keeps going, then I think there's a chance to everyone comes to an agreement that stop it. Obviously is extremely unlikely, but I think it's better to like remain optimistic about that. And there's also a funny tweet that I've seen right now before streaming that, and this is something that I argued about, I think, with some people like a long time ago. Like people saying that, well, we can just keep AI on a box, like how dumb the argument is. And everybody was thinking about that, and now then the tweet says that like everyone in 2010 or whatever can keep it on a box, and then look at how we are now, where they're making plugins for the thing. It's pretty dumb that you think that you can contain something that is extremely intelligent. So it reminds me of the movie where I think it's Hannibal Lecter. One scene from the movie where he's in prison and then the person goes and talks to them. It's kind of very similar to that, where people don't realize that they are part of the system and they are flawed. So because usually these people are smarter than average, and maybe like at the very end of the distribution when it comes to IQ or something like that. So they become delusional. I think I'm gonna focus more on the. Maybe I should ask ChatGPT how to use ChatGPT 4. Maybe ChatGPT is already using GPT-4. I think I'm gonna focus more on the other things studying in ngraph. I think what I'm gonna do is just copy the code from the example there. And this file here uses all the other files. So I think I need to create some like a folder or something like that here. The question is where to put it, because I might create this on a. It might be better to put this on a store because it's gonna be updated. But I think I'm gonna put outside here for now, lib. And then it's just gonna be the same. Just copy everything that is here. Maybe I should download everything because it's gonna be easier to pass to the project. But I disagree with people as well that think that like is completely over. I think that it's not that it's over, it's just that it's unlikely. Like it's unpredictable to know what's gonna happen, and it's gonna happen extremely fast. So this is like kind of unsettling, let's say. Both on the micro and the macro perspective. But I still think that the best shot is like, even though I think that like realistically there isn't much anything can do about it. Anyone can do about it because of the whole way that the macro system works. Like I still think that from the point of view of like an individual, you have to focus on what you can control, and then from that point of view, I think that the thing that would maximize the chances as much as possible of creating something that is in alignment with life, let's say, would be to figure out the Nash equilibrium of MEV on a blockchain protocol, and then also figure out, like, because inside of the nodes you would have to put the heuristics that are in alignment with the laws of physics that are going to be inevitably based around a lot of assumptions over what determines the boundary of something that is alive, let's say, because it's always relative. So, and this is always going to be like paradoxical discussion because it's the boundary between philosophy and science. So because the perception is what creates the symmetry, so you're always gonna have people on both sides. One side is gonna say that everything is conscious, the other side everything is material, and then the paradoxical point, which is the superposition of them, is probably most likely the truth. But then has infinite complexity because it's a self-fulfilling prophecy that creates the nature of perception, which is a relativistic multifractal symmetry. I'm gonna copy. And this is the example there. And I'm looking into other examples. This one I can't really click on the thing, but there are some examples there where you can. And I imagine it's just putting the event listeners, but I'm gonna look into the code now here to see how they do it. I think it's great graph scene. I have to see if I downloaded the file as well, the library. Yeah, here. I'm gonna look on this one to see how they initialize the graph there. Yeah, I think that's how they do it. So just import this and then put. And first, I just try the simple thing, which is do exactly what they do there. Import this and then use this on the mount. I think I did some stuff here before. Draw graph. Yeah, this is with the help of ChatGPT, I think. But I think this stuff is wrong. Because I remember looking at it and then there wasn't any layouts. There's a force layouts library, but no layout. And I think this library doesn't exist as well. Like create renderer. So let me put the stuff here. Yeah, I think I need to. Maybe the create layout is fine to put. I need to see what are the equivalents of the events for Svelte, because there is one. Vue.js. Yeah, so maybe. This is something else that I have to change. I think this is fine because this creates a graph. And then the ngraph is on the function. And then this I have to change the path here. I was also looking into how to use plugins, so maybe I'll watch these videos here.
Hi, Jason here. So yesterday, OpenAI did another massive big release, and this time it is for ChatGPT plugins. So this is going to be huge. AI is just moving so fast at the moment. You can barely catch
As far as I understand, plugins are the things that allows you to connect ChatGPT to the internet. And then this LangChain here is some API that allows you to break down text into tokens and convert to use it on ChatGPT or something like that. And the video I've seen from this stuff is where you create something that reads the PDF using this stuff. So it breaks down the text into tokens, and then you can automate the process of communicating with ChatGPT, I think, and using this thing. So one idea that I had, which probably someone else has had already, they should just use this thing in ChatGPT to look at my own code. Because the thing that, and this is, I'm already doing this manually with the other projects, but the thing is that it takes a long time for you to set up the whole history for ChatGPT to know. Like, as soon as it gets, for example, the stuff that I'm doing with the poker software, as soon as it gets to more complex stuff where you have multiple different files communicating with each other, then it becomes like very annoying to do, because you have to put all the code and then explain everything like step by step. So if you could create something that automates this, then like the thing would understand everything, like the whole software design of the stuff that you're doing, and then you can optimize the code. This one also changed some stuff here that I realized. Like, I was adding the bats to the flop and turn bats because the node ID requires them, but then I realized that I was adding them to the normal lines, which is not correct. And also, that's something that uses memory, so I wanted to remove that anyway. This is the reason why I was investigating, and then I removed that, and then I figured out that there was another mistake, because and this was a mistake that I already thought about, but for some reason it was working before when I was adding the bats. I think it's because it was analyzing the last lines, because the size of the pot was increasing. So the problem was in the donk line, where I have the same current player, previous player, and then to calculate the current actions here, it wasn't working. So I modified the previous actions to not take into account which player it is, and I spent some time refactoring this more. And then I ran again and it's working now. But the thing is, this is still really slow and takes a lot of memory. So obviously what I wanted to do is to see if I can optimize this much more. But the problem is that in order to use ChatGPT for something like this, I have to make it understand the whole software design of all of everything that is involved. And also I would need it to come up with maybe new ways that create new software design, let's say, than this one. But this is what I mean, where it's one of those things where I thought about this obviously before, but it starts getting really tricky because you don't know like to what extent your actions are making more likely that there is gonna be like some catastrophe, even though it seems like it is impossible because it like it seems like you don't have that much of an impact, let's say. But yeah, if you like use something like this, and then let's say I succeed in making it understand more software design, then maybe someone else can build on top of that, and then before you know it, like the thing is creating software automated, and then it's thinking for itself, and then it's communicating with the whole internet, and then like it becomes something else that you can't even think about it. It's the exact same thing that happens with the social media a while back, that nobody understands like what is actually going on until people finally realize that like there's all this war happening and stuff like that for data and manipulation and politics and stuff like that. And then you get into the cancel culture and things like that. But in the beginning of the internet, like it's very few people think about this, like all the possible consequences, and even those people can't imagine everything that can happen based on the small actions. That's the problem. So it's hard to know like if I should do this or not, try to incorporate this stuff or not. And there's also the additional problem with this that I see, like a lot of people starting stuff with ChatGPT, where they pretty much just put like a layer on top, and their whole app is just using ChatGPT and rebranding, like for something else. Like you're pretty much just arbitraging ChatGPT. And also not only for this perspective of AGI, but for the perspective of like the business model, it is like doesn't make any sense to me. It's like I can't think about it like that, where you're gonna create the entire business that is dependent on another company, and they can change their mind or whatever like tomorrow, and then everything, like your whole thing is over. It seems like very like not very good strategy to me. But then again, it's not black and white, because then you can make the argument that you can use that, like you can run the risk and then make the money and then just exit, and then you'll be better off than if you didn't. So, and then there's all these macro consequences and everything that is connected that makes it really hard to think about it, to reason about these things. I was gonna ask something to ChatGPT, forgot. Yeah, so now this is one of the issues that I was thinking about before. It worked when I just had the create graph here, but from what I've seen on the library, it looks like it talks about some stuff about browserify, and then how, because usually in the documentation, the way that it talks about it, he's using require to connect the modules, which means that it is using on the server side. So I'm not really sure if this library, like from what I understand so far, is it should work on the browser as well. But it might be more difficult to make it work on the browser. So I think this error here is because of that. Something related to that. It's probably because I have the wrong path here. So I put true libs. But I don't understand. I think WebGL, from the videos I watch, is supposed to work on the browser. It is pretty much exactly the same as a canvas. You just pass a different context, which is the WebGL context. And the only difference is that you're passing vectors and something else, fragments, I think, vectors and fragments to the buffer, and then the buffer goes to the GPU, and then from the GPU it creates the visualization. From the concept level is very similar. The only difference is that you use another language to communicate. You have to create these vectors, but then there's libraries that do that for you as well. Let's see. I didn't change, maybe. So. And now I think it should be on the correct, so it's probably something else. Let's see if I do like this. And so I think I'm gonna have to put JS on everything. First layouts, I think I don't need. Oh, maybe it's because I don't have the library. I think this one I didn't fork because it isn't part. It wasn't part with the. Didn't have the ngraph on the name. So I'm gonna install like this, but I'm gonna also fork here. I should put ngraph on the name. I'm just gonna see if it works first, and then I'll worry about understanding how it works. Okay. We're gonna remove this one. It's probably not gonna work. Okay, finally. It's interesting that it didn't complain on this one, but it's probably because of the way that because of this stuff that I'm importing. Because I think that this one maybe has these files have stuff related to the layout, but I'm not really sure. And I don't understand why it's not showing anything, even though there isn't any data, I think. I think I didn't fork this one, so I'm gonna do that.
Hello guys, my name is Sanjay, and this is a story of monolith library which I rewrote into small modules. And in this talk, I'm going to show you what opportunities that opened up. In my previous life, I used to be a .NET developer. I wrote Silverlight WPF applications, but they kept saying Silverlight gonna die, JavaScript will kill Silverlight. So I decided to check if it's true. I got this book, read it, and as an exercise, I created this graph drawing library. Graph is a collection of vertices and edges. This graph here, it has 2,000 vertices, 6,000 edges. You can render something larger than that. This is 20,000 edges and 5,000 nodes, and it is really customizable. You can change lots of different arguments here. And the library itself is rendering agnostic, which means it can render using different technologies like WebGL or SVG or even CSS if your browser does not support SVG or WebGL. So needless to say, I never returned back to Silverlight development. But when I was doing this library, I reinvented a lot of wheels. For example, how do we normally structure our JavaScript applications? We have a collection of small files, then we concatenate those files together using tools like Grunt or Gulp or CAD to produce a release. And then we put this release somewhere into distribution folder, upload it to GitHub for everyone to use. And what we do inside of each file is really up to developers. Sometimes we wrap content to the files into immediately invoked function expression, pass context in that expression, and augment that context with our public API. If we are coming from a .NET or Java background, we try to mimic that with something similar to namespaces. But neither of these approaches is perfect. There are many problems. Scope is one of them. For example, if you forget to put expression into function body here, and after we concatenate all those files, we'll end up being in a global scope here. Another huge problem is dependency resolution. For example, what if our library depends on some third-party library? What do we do? Do we include that into our bundle, or do we tell every developer to include that library into their HTML pages? And then we start to worry about the order of execution. So these are the problems which developers face during development of the library. But then how do users of the library use it? So they go to github.com, they download release, they include it into HTML file, then they start using it, and then they hope it will not break. They hope the dependencies are all satisfied and there is nothing else is overwritten in the way which shouldn't be overwritten. This library, VivaGraph itself, the way it is written right now, is 6,000 lines of code. It's really a large library. It offers a lot of functionality, and it's really huge. And that's actually not a problem. What if someone needs to use just a small part of your library? Like this guy, he only wanted to use graph generators, but he didn't really care about visual aspect of the graph, how to render that graph. So what does he have to do? Well, copy-pasting just graph generators into his code does not make much sense. So it doesn't make sense to use entire 6,000 lines of code, right? And the solution to that is small modules and NPM. NPM stands for no prescribed meaning. Some people call it Node Package Manager, and what it does is it actually manages packages for Node. Each package in Node is just a collection of files. Usually JavaScript files in that package are written in the CommonJS format. In CommonJS, you clearly declare what your file exports, and if you need something, you just require that something. What's really nice about CommonJS is each file represents a scope. If you do not export something from your file, it remains hidden. No one will see that variables which are not exported from the file. This works really well in Node, but what do we have to do in the browser? And the answer to that is Browserify. You can think of Browserify as a smart concatenation tool which knows how to concatenate CommonJS modules and teaches the browser what is CommonJS. Let me actually give you an example here. So in this folder, you have index.js and foo.js. Index.js requires foo.js, and foo.js just prints hello world to the console. So if you run this in Node, no surprises, hello world. Now, if you browserify this file, you see, we have concatenated bundle with all our functions, and a small code over here which teaches the browser what is CommonJS. It teaches what is require, what is module, and what is exports. That's it. Very, very simple, very clever, very small. But after we do this, and let's say output result of browserify bundle into file, then include this file into our HTML file here, like this. We can start using this in the browser. You see, hello world. So if someone needs to use just generators, what we do, we require a package which knows how to generate graphs. Then we create a grid graph 10 by 10 here, and in this example, we just print number of nodes at that graph. So if you run this in Node, 100 nodes in 10 by 10 grid graph. If you open this in the browser, again, 100 nodes, so code starts to be reusable in both platforms. So I started redoing my library into small modules. There is a separate module which knows how to construct the graph, how to add nodes to the graph, how to remove nodes from the graph, and nothing else. That's just its only responsibility. There is a separate module which knows how to construct Barnes hot tree to effectively simulate an embody force problem. Oh, sorry, just embody problem. And there's a separate module which knows how to integrate physical forces, how to work with physics. Now, composability is a huge part here. If you combine these three together into one package, you'll end up actually having a force-based graph layout module, which knows how to lay out graph in memory, but it doesn't really care about how you represent the graph on the screen. So for that, there's a separate module which you can use to render graphs with your favorite rendering library. Here's an example of Fabric.js library which renders graphs in using Fabric.js, very famous or very popular 2D drawing library. For example, this is a 10 by 10 grid here. You see it animates rabbit here, and this is interactive. You can zoom in, zoom out using mouse wheel, and this is rendered by Fabric.js itself. What's really nice is that this graph over here and these images here were created by exactly the same code. Fabric.js knows how to render images when you run it in Node.js. So just use that to render these images here and use it to render graph over here. Just amazing. And because everything is abstracted, you can actually create a separate module which knows how to render graph in, for example, the terminal. So this module here, it renders graph using ASCII symbols. So we create a grid graph 10 by 10 here, and then we require that ASCII symbols rendering module, and then we just render it here. So if you run this in the terminal, you see it starts being like 10 by 10 grid graph using just ASCII symbols. Or let's say, change it to something more fun. Let's say path, 100 nodes, and then just run this here, and you see it starts forming a shape of a path. Because everything is abstracted, it is usually very easy to swap out different parts. So for example, in this example, I'm actually pretending in the browser that my browser is a terminal. So you can see a 10 by 10 grid graph rendered with ASCII symbols with the same module, but in the browser. So with this approach, you kind of become a yes man. If someone comes to you and asks you to implement a feature in your library, like this guy, he wanted to add support for Gephi files. Gephi is a very popular open source graph analysis and drawing tool, which is a desktop application. It is a really nice tool, but with an analytical library, you would double think, do I really need to include this functionality to my library? Or maybe I don't need it. It's already 6,000 lines of code. Does everyone benefit from using that integration? With small modules, you just tell yes, you just create a new module and publish it, and you're done. Like here, I created this small module. I showed how to import files into Gephi or how to export files from the Gephi, and you just make people happy with this approach. Because everything is so abstracted, like 3D is another amazing thing, but again, with a monolith library, you need to be careful about adding more stuff into it with space, any links, but which has module to parse position, because I already had 2D parts flying over there by this library itself. So, and if you keep zooming out, you'll see a small ring of isolated packages forming like.
I knew I was missing something as well when it comes to this, because I remember seeing some visualizations in 3D and stuff like that. So I knew when I was using VGS that there must be something out there that is different and is more efficient. So hopefully this one, the graphs with a lot of nodes are better, which I think they will be. It's just going to be a challenge to figure out. Here I'm sending the data and it's getting the data, but it's not showing there. And it's going to be tough because I have to understand more how Svelte works under the hood, I think, how it updates the stuff. But I think it's pretty simple. It should be really simple, which is just the same lifecycle hooks that other frameworks use to update the UI. And this stuff here about the packages, I also thought it was interesting when I saw this for the first time, because it's a giant ball in the middle, and then there's a bunch of things here. And I think that this just mimics gravity, the way that gravity is, because it's the whole thing that I was talking about before, and the whole, like, not the whole reason, but one of the reasons why for doing this visualization stuff, which is that all these libraries here are just exemplification of how the electromagnetic field shapes itself over time, I think, because it's an informational system, so the configuration of the code is like the geometrical structure of the electromagnetic field over space-time. And because of that, I think that this is why the packages follow this pattern here, which is similar to the pattern that planets follow. Some planets where you have a lot of mass in the middle, and then you have like the other objects surrounding that mass. I think it's just a fractal pattern of the way that gravity works. And that's the reason why the packages are this way. Maybe, but maybe not. So this is the reason why I think that there is this correlation between the geometry and the in consciousness and programming and everything. So I think that the AGI is probably going to be a multifractal geometry, because if you think about it, that's all that everything is. And the complexity of the human being and the thoughts and identity and stuff like that is just a multifractal geometry of the biochemistry that creates the electromagnetic field of a person's body, which is just a multifractal geometry. So I think that for AGI is going to be analogous, but in a different scale, where you have the whole internet, and then it evolves through some multifractal geometry that creates like this super powerful conscious, but whatever the fuck that means, because it's really hard to know what consciousness even is. Yeah, but I think that maybe I'll do this, but I'm not really sure. But using the ChatGPT to create this connection between geometry and the model should be the way, I think, probably. But it would be better, obviously, if I could figure out a way to put that in the blockchain. Like, not just any blockchain, but create, because that's part of the challenge as well, I think, because blockchain is just a multifractal pattern as well. So it's figuring out what's the correct multifractal geometry of the structure of a network, that over the electromagnetic field, it doesn't destroy itself over time, because it has a perfect balance, like it's harmonious between the nodes of the network that create the information in the first place and creates the feedback loop of the learning system.
Of isolated packages forming like asteroid ring here. Let's zoom in a little bit here. So you can see in the middle are very popular packages like this one here. It's Lodash, one of the most popular packages on NPM. This is request, this is async, and this guy here is underscore. So if we keep zooming in here and see this gray area is actually all connection, all dependencies. We can zoom in here. It's a lot of dependencies, lots of modules here. So on the edges of this graph, there usually tends to be like namespace libraries like this thing here. Look at the name. Everything starts with generator. Can you guess what the thing in the middle is? Yay, it's Yeoman generator. So this thing over here is everything related to Lodash. If we go somewhere else, like to this area, you see everything is related to Wiki. And ngraph itself, this graph library, it forms a small group over here. So I always knew that in Node, it is common to have tests. Like people try to cover their code with tests. And it's not surprising because with that many packages, if you want your package to be legit and if you want it to be noticeable, you have to cover it with tests. You have to have good documentation. It's just common practice. But I actually never saw how many packages were covered with tests. With this visualization, I thought I can easily do that. So here, you ready? If I click this highlight covered with test, it will show all packages covered with test. It is 29,000 packages out of 62,000 packages. The good thing to Yeoman, you see how they cover almost all their packages with test. So really nice. Here's maybe it could be just this. So this is the principle we need. Exactly the same pause to export everything.
Maybe on destroy is not after. On destroy is after mounted, and before a mount is something else. So maybe this is wrong. So I think I'm not gonna put that for now, because I think that is not the reason why it's not showing the graph. I'm just gonna have to understand. Maybe I can copy this code and then ask ChatGPT to explain. So I don't need these miserables in the first place. So maybe that's the difference here. I have to understand how the miserables create the graph, and then figure out how to replace the code there with my own stuff. The issue is that I'm not gonna be able to put here, I think, simply because I need the data from the WebSocket. That's the thing that it makes it difficult, I think. More difficult because like when the page loads, I'm not gonna have a graph. I want the graph to be updated when the thing, and maybe I need to set the canvas height and width and things like that before. So I only want the graph to be updated when the script is run. Yeah, so these would be the parts. I'm creating the graph from here. So one thing I can do is put another argument here and then pass the graph instead of using this get graph here. I think that's what I'm gonna do. There's also another thing that I saw that is WebGPU, and I think is more advanced version of this, but I think not all browsers have that yet, so I think it's better to use WebGL first. And it should be showing me the graph, so I think there's a other mistake other than, I think there's two mistakes. One is that I'm not getting the correct graph, but it should be showing the graph because I have this module now. So it should be showing the same graph from the other project. There's probably something with Svelte that I'm doing wrong there. Or is because I don't have the graph when it initializes the thing.
Quick start guide hashtag. This tutorial gives you a quick walkthrough about building an end-to-end language model application with LangChain. Installation hashtag. To get started, install LangChain with the following command. Pip install LangChain. Environment setup hashtag. Using LangChain will usually require integrations with one or more model providers, data stores, APIs, etc. For this example, we will be using OpenA's APIs, so we will first need to install their SDK. Pip install OpenA. We will then need to set the environment variable in the terminal. Export OpenA underscore API underscore key equals. Alternatively, you could do this from inside the Jupyter notebook, or Python script import os. os.environ OpenA underscore API underscore key equals. Building a language model application, LLMs hashtag. Now that we have installed LangChain and set up our environment, we can start building our language model application. LangChain provides many modules that can be used to build language model applications. Modules can be combined to create more complex applications, or be used individually for simple applications. LLMs get predictions from a language model. The most basic building block of LangChain is calling an LLM on some input. Let's walk through a simple example of how to do this. For this purpose, let's pretend we are building a service that generates a company name based on what the company makes. In order to do this, we first need to import the LLM wrapper. From langchain.llms import OpenAI. We can then initialize the wrapper with any arguments. In this example, we probably want the outputs to be more random, so we'll initialize it with a high temperature. LLM equals OpenAI, temperature equals 0.9. We can now call it on some input. Text equals what would be a good company name for a company that makes colorful socks. Print, LLM, text. Feed full of fun. For more details on how to use LLMs within LangChain, see the LLM Getting Started guide. Prompt templates, manage prompts for LLMs. Calling an LLM is a great first step, but it's just the beginning. Normally when you use an LLM in an application, you are not sending user input directly to the LLM. Instead, you are probably taking user input and constructing a prompt, and then sending that to the LLM. For example, in the previous example, memory, add state to chains and agents. So far, all the chains and agents we've gone through have been stateless. Agents dynamically call chains based on user input. Chains combine LLM, prompt templates, manage prompt, LLMs, get predictions from a language, building a language model application, LLMs hashtag. Now that we have installed LangChain and set up our environment, we can start building our language model application. LangChain provides many modules that can be used to build language model applications. Modules can be combined to create more complex applications, or be used individually for simple applications. LLMs get predictions from a language model. The most basic building block of LangChain is calling an LLM on some input. Let's walk through a simple example of how to do this. For this purpose, let's pretend we are building a service that generates a company name based on what the company makes. In order to do this, we first need to import the LLM wrapper. From LangChain.llms import OpenAI. We can then initialize the wrapper with any arguments. In this example, we probably want the outputs to be more random, so we'll initialize it with a high temperature. LLM equals OpenAI, temperature equals 0.9. We can now call it on some input. Text equals what would be a good company name for a company that makes colorful socks. Print, LLM, text. Feed full of fun. For more details on how to use LLMs within LangChain, see the LLM Getting Started guide. Prompt templates, manage prompts for LLMs. Calling an LLM is a great first step, but it's just the beginning. Normally when you use an LLM in an application, you are not sending user input directly to the LLM. Instead, you are probably taking user input and constructing a prompt, and then sending that to the LLM. For example, in the previous example, the text we passed in was hard-coded to ask for a name for a company that made colorful socks. In this imaginary service, what we would want to do is take only the user input describing what the company does, and then format the prompt with that information. This is easy to do with LangChain. First, let's define the prompt template. From LangChain.prompts import prompt template. Prompt equals prompt template. Input underscore variables equals product. Template equals what is a good name for a company that makes product. Let's now see how this works. We can call the .format method to format it. Print, prompt.format, product equals colorful socks. What is a good name for a company that makes colorful socks? For more details, check out the Getting Started guide for prompts. Chains combine LLMs and prompts in multi-step workflows. Up until now, we've worked with the prompt template and LLM primitives by themselves. But of course, a real application is not just one primitive, but rather a combination of them. A chain in LangChain is made up of links, which can be either primitives like LLMs or other chains. The most core type of chain is an LLM chain, which consists of a prompt template in an LLM. Extending the previous example, we can construct an LLM chain which takes user input, formats it with a prompt template, and then passes the formatted response to an LLM. From LangChain.prompts import prompt template. From LangChain.llms import OpenAI. LLM equals OpenAI, temperature equals 0. We can now create a very simple chain that will take user input, format the prompt with it, and then send it to the LLM. From LangChain.chains import LLM chain. Chain equals LLM chain, LLM equals LLM, prompt equals prompt. Now we can run that chain only. There's the first chain, an LLM chain. This is one of the simpler types of chains, but understanding how it works will set you up well for working with more complex chains. For more details, check out the Getting Started guide for so far the chains we've looked at run in a predetermined order. Agents no longer do. They use an LLM to determine which actions to take and in what order. An action can either be using a tool and observing its output, or returning to the user. When used correctly, agents can be extremely powerful. In this tutorial, we show you how to easily use agents through the simplest, highest level API. In order to load agents, you should understand the following concepts. Tool, a function that performs a specific duty. This can be things like Google search, database lookup, Python replace, other chains. The interface for a tool is currently a function that is expected to have a string as an input, with a string as an output. LLM, the language model powering the agent. Agent, the agent to use. This should be a string that references a support agent class. Because this notebook focuses on the simplest, highest level API, this only covers using the standard supported agents. If you want to implement a custom agent, see the documentation for custom agents, coming soon. Agents, for a list of supported agents and their specifications, see here. Tools, for a list of predefined tools and their specifications, see here. For this example, you will also need to install the SERP API Python package. Pip install Google search results. And set the appropriate environment variables. Import OS. os.environ_API_key equals. Now we can get started. From LangChain.agents import load_tools. From LangChain.agents import initialize_agent. From LangChain.llms import OpenAI. Hashtag first, let's load the language model we're going to use to control the agent. LLM equals OpenAI, temperature equals 0. Hashtag next, let's load some tools to use. Note that the LLM math tool uses an LLM, so we need to pass that in. Tools equals load_tools, SERPAPI, LLM math, LLM equals LLM. Hashtag finally, let's initialize an agent with the tools, the language model, and the type of agent we want to use. Agent equals initialize_agent, tools, LLM, agent equals 0 react description, verbose equals true. Hashtag now let's test it out. Agent.run, what was the high temperature in SF yesterday in Fahrenheit? What is that number raised to the 0.023 power? Entering new agent executor chain. I need to find the temperature first, then use the calculator to raise it to the 0.023 power. Action, search. Action input, high temperature in SF yesterday. Observation, San Francisco temperature yesterday. Maximum temperature yesterday, 57 degrees Fahrenheit, at 1:56 p.m. Minimum temperature yesterday, 49 degrees Fahrenheit, at 1:56 a.m. Average temperature. Thought, I now have the temperature, so I can use the calculator to raise it to the 0.023 power. Action, calculator. Action input, 57.023. Observation, answer, 1.0974509573251117. Thought, I now know the final answer. Final answer, the high temperature in SF yesterday in Fahrenheit raised to the 0.023 power is 1.0974509573251117. Finished chain. Memory, add state to chains and agents. So far, all the chains and agents we've gone through have been stateless. But often, you may want a chain or agent to have some concept of memory so that it may remember information about its previous interactions. The clearest and simple example of this is when designing a chatbot. You want it to remember previous messages so it can use context from that to have a better conversation. This would be a type of short-term memory. On the more complex side, you could imagine a chain/agent remembering key pieces of information over time. This would be a form of long-term memory. For more concrete ideas on the latter, see this awesome paper. LangChain provides several specially created chains just for this purpose. This notebook walks through using one of those chains, the conversation chain, with two different types of memory. By default, the conversation chain has a simple type of memory that remembers all previous inputs/outputs and adds them to the context that is passed. Let's take a look at using this chain, setting verbose equals true so we can see the prompt. From LangChain import OpenAI, conversation chain. LLM equals OpenAI, temperature equals 0. Conversation equals conversation chain, LLM equals LLM. Building a language model application, chat models hashtag. Similarly, you can use chat models instead of LLMs. Chat models are a variation on language models. While chat models use language models under the hood, the interface they expose is a bit different. Rather than expose a text in, text out API, they expose an interface where chat messages are the inputs and outputs. Chat model APIs are fairly new, so we are still figuring out the correct abstractions. Get message completions from a chat model. You can get chat completions by passing
All right, this is Mel, and this is a brief.
Oh, there we go. Finally. Let's see if it works with the data there. The problem is that it's not showing anything. So even there when it was showing, it didn't have any nodes. So there's still something I'm doing wrong. Oh, it's saying that it can't read length of no, so it's probably this mistake here. This is the issue. It's the same problem that I was trying to figure out before. But maybe I should include this on the other one. On the draw graph function. Because the problem is I can't await these things here. So it's kind of weird. Because the issue is that I'm doing this on the beginning. But I want to do this only when I receive data. So I think I'm just gonna see if I can ask ChatGPT. Oh, I can update this star. Oh, but that doesn't make a lot of sense because the star is just the events. So I forgot to delete this. Oh, it's updating here. And this is the thing that is hard for me to think. Because I think it's saying me to update the graph inside of the star, but I think that doesn't make any sense. But I don't understand really well how it works or how to organize this so that it works. Because this star should be only for the sockets. And the unknown mount is subscribes to the star, which is created here. Yeah, it's created through this function, but it's get it from here. Because they are from the same file. So this is gonna listen for the events because the WebSocket creates the events inside of the star. And then it subscribes here. Yeah, but I don't understand really well what's the point of subscribing here. And the thing is, I think I need to update whatever I put inside of this code has to be related to the logic that exists on the star. And because I create the star as a writable that has these two variables here, it doesn't make any sense to, because this is not this is the data for the graph, it's not the graph. So it doesn't make any sense to put the logic to create the graph inside of this thing here. And I know that this $sign is used for reactions, so maybe it does make sense to create something like make the canvas or something like that reactive to the star, which I don't know really how to do. Now we can put objects like this. I don't understand really well how it works. Because the issue is obviously this code. Like regardless if I put this there, I think it doesn't matter. Because the function is going to be running when the component mounts into the page, I think, with this on mount here. And then it runs the function, and then it's going to run this thing here. But that this time I may not have the the data. But I think it should, but that's the thing. Maybe it's just updating when I receive the data because I'm using the subscriber event here. Maybe you should change the star though for the WebSockets. But like that's intuitively it feels like it doesn't make sense. Because I have to separate the star for the WebSockets from the graph. Yeah, this is the thing that maybe this way it works. So I have to put it outside the amount. I think in this case, but that's the thing, how I'm gonna do it. Because if it's not dependent, it's dependent on the graph here. But the graph is the data in this case. Maybe I should change the name so I understand better. It's slightly confusing. Not sure if this is gonna fuck up though. Because of the name that it has to have on the WebSocket store. And so the thing is, maybe I shouldn't put this stuff here, because then I can use it like this, where I just pass the data. And this is not gonna be, I think this is gonna be the two variables here. Maybe I'll change the name there as well. Just put graph data. Change here. And now I might fuck up here. It's probably because of the other. Because I deleted it from here. Yeah, but it doesn't make sense because of the error that I'm getting. So I have to do that here as well. Yeah, there we go. So now it shows something at least. Better than nothing. There's still a problem with creating the nodes. So it's probably something along the lines, like inside of the function somewhere. Like inside of these functions here. So I'm gonna have to spend some time studying them. Obviously, I'm gonna do anyway, but I was just trying to see if I can at least like make this simple graph there. The simplest way that I can. So it looks like it's using a font somewhere, but I think this is not the reason why it's not loading the thing. I'm gonna stop here. I'm gonna read this file, study this file and the other ones off stream. Probably gonna continue this 2 days from now. I think that so far what I'm probably gonna do, I think I might go back to work on this as well. Now that I have this thing that the thing that sucks about this one is that like I need to figure out a way to optimize this. Like I think there's something wrong with the way that I'm doing, because the way that when Pio creates the tree, it uses a lot less memory than when I'm creating, but it might be for several different reasons, and that's the problem. But I want to have something that I can list, like automating the process of node locking doesn't sound that hard to me, I think. So I might focus on that now, like as a separate thing. Then once I figure that out, then I come back and join the things together again. Because the thing from here, what I was gonna do is to just use which I'm still playing a lot of hands now, so I need a significant amount of hands to be able to see. So this is the reason why I think that's not worth so much to try to do with the thing with the data now, because I don't have as much data. But yeah, the plan would be to, now that I have the tree, I have something that creates the tree from the batch sizes, the batch structure. Then I can just go over the data, and I can, as I go over the data, I navigate through the tree and update the ranges, create the ranges and update them. Well, that's another optimization I think I'm gonna do here, which is I'm not gonna create the range as I create this thing here. I'm just gonna leave it as an empty dictionary, And then instead of doing that, I will create the range as I go over the data. I think that's the better approach. And then with the data, I update all the ranges, and then I create something that searches for the tree and sees like what are the ranges that have the highest significant statistical relevancy, let's say. So the lines that were most played and that are most relevant. Then based on those lines, then I node lock with the ranges that I get. I node lock with Pile on the simulation. The first step, I think actually before that, would be to create the simulation using navigating the tree. I actually don't even need to navigate the tree because I'm storing all the possible lines. The only thing I will have to do is loop over the all possible lines that I'm storing on the thing, and then replace the bats with the correct value, because I'm getting the actual value instead of getting the cumulative value. And then Pile Solver uses the cumulative value for building the node IDs. So for building the lines, I think it uses the cumulative value as well. But I will loop over all possible nodes, then get all possible lines from that, then create the simulation from that. Then after creating the simulation, then I can either solve the simulation or I can just do the stuff. I think solving the simulation probably first is better than having a lot of simulations. And then based on those simulations, then I use the data to node lock, doing the process again. Yeah, but I might come back and not focus on this so much and just focus on the other part, which is to just create the process of automating the node locks, I think. And then later on I join them together. But I think for now I'm gonna focus more on this one until I have something that I can visually see the graph there from the backends of the connections. And then I think it might be interesting as well, but I'm not really sure about it because I don't know, like there's all these questions about AGI and all this stuff that can happen. So I'm not really sure what to do about it, but I might try to incorporate some stuff from, like use these APIs here from OpenAI, try to use this stuff here to combine both the visualization with the language models in order to create something that allows you to visualize the whole software design of whatever you are interested in, and then just do that for a bunch of different software until I have something that is like a multifractal model that associates geometry with problem solving. So, but I'm not really sure about it. So I think I'll probably continue this tomorrow or 2 days from now to continue to build this website here and to study WebGL and the other stuff.